Okay, today we continue with properties of exponents and we have to learn what the power rule is. So expressions like these are often called powers, or in particular this number right here. So for example, this can be read as 3 to the 4th power or 3 with the power of 4. But now we want to consider the possibility of an expression that already contains a power getting raised to another power. For example, 3 to the 4th being raised to the 2nd power. So now if we use the definition of exponents, we can look at 3 to the 4th as being the base. So here, 3 to the 4th, we have to write it with a multiplicity of 2. So we're going to write 2 copies of that because of this exponent right here. But now we can rewrite this as 3. And remember, what we learned the other day was that whenever you have the same base, you can add the exponents together. So we can rewrite this as base 3 to the 4 plus 4, which is going to give us 3 to the 8th power. And after analyzing this for maybe about 10 seconds, we can see that there's a relationship that went on here. So here we can think about the powers getting multiplied together to get the resulting exponent. So 4 times 2 is going to give us 8. And that's basically the power rule. And that's always going to happen, not just for this example, but for any example we decide to choose. So let me give you a definition. So now suppose m and n, these ones right here, represent exponents. And suppose that x represents a base. Then the power rule tells us that when you have a power getting raised to another power, you can multiply these powers together and keep the same base. So let's look at this example right here. So it says simplify and leave your answer in exponential form. So if we follow the power rule, here 4 is the base and 3 and 5 are the exponents. So I can rewrite this as 4 to the power of 3 times 5. And then 3 times 5 is a total of 15. So that would be the simplification here. Alright, let's take a look at this one. This also works for variables. So here we have the base x, and then the powers are 7 and 12. So I can multiply them together because we have an exponent getting raised to another exponent. So now the result here is going to be x, and then 7 times 12 is 84. Now the power rule is also very nice because it distributes. So for example, let's say we have 2 bases. So here I have 4 and I have 2. These are 2 different bases. This power of 2 is actually going to get applied to this base and to that base. So this can be rewritten as 4 to the 7th raised to the 2nd power times 2 to the 3rd raised to the 2nd power. And now we can apply the product rule to each part here. Let's begin with this one here. So here we get 4 to the power of 7 times 2, getting multiplied by 2 to the power of 3 times 2. So we get a grand total of 4 to the 14th times 2 to the 6th. And that would be the final simplification here in exponential form. So let's do one last one. So here we can think about 2 having a power of 1. We can think about x having a power of 1. And now we're going to distribute this 3 here. So we can rewrite this as 2 to the 1st power getting raised to the 3rd power multiplied by x to the 1st power getting raised to the 3rd power. So here we get 2 to the 1 times 3 multiplied by x to the 1 times 3. And our grand total is 2 to the 3rd, x to the 3rd. Alright, that's it. So we'll try them out. And Any questions, again, please message me.